In this video, we will go over a very brief introduction on setting parameters in PtyRAD. Parameter setting is incredibly important as the success of a typography reconstruction is dependent on finding the right parameters for your particular dataset. A reconstruction in PtyRAD is fully configured by a single YAML parameters file, and all you need to do is edit one parameter file to set the parameters. So if you go into your PtyRAD package, there is a demo folder inside which you will find a params folder, which has the parameter files corresponding to the demo reconstructions that come with the package. You could, if you didn't download the entire package, then you could also find these on GitHub as well. Here, there are two main types of parameter file structures. One is basically, quote unquote, the normal one, which is this one. And the other one is the so-called minimal one. And the normal one contains all the parameters that PtyRAD can take, and you can customize and specify them to fine-tune your reconstructions. For beginners, this can seem like a lot of parameters, so there is a minimal one that contains basically only the bare minimum parameters that you need to specify for each reconstruction that you will run. The rest of the parameters that are not included here will be set to default values, and the nice thing about this minimal params file is that if you need to ever tweak any other parameters, you just put it in here along with these parameters. So you don't necessarily have to go through the full parameter file like this one to adjust just one or two more parameters. Okay, so what we'll do in this video is explain what these key parameters are and how to set them for your reconstruction. As an example, we'll take a look at this twisted bilayer tungsten diselenide demo params file. So if you go here, half of these parameters correspond to your experimental data and have quote unquote the correct values that you should know before attempting typography. When you're taking experimental data, you should take note of first the electron energy in keV, the convergence angle in MRAD, the defocus, and we use a negative underfocus convention, the size of the diffraction pattern or the number of pixels in your detector. This is 128 for both MPAD 1 and 2. The number of scan positions along the slow direction. This is typically the Y direction for many rastering algorithms. The number of scan positions along the fast, typically X direction. And for these, the typical size is 128 or 256, though you can do 64 or 512, I guess, if you can do that. We also need to calculate the scan step size, which is the real space field of view in angstroms divided by the number of pixels. And it is very important to use the field of view or field of view corresponding to a particular magnification that is carefully calibrated to your microscope. The flip and transpose of how your data is collected. This is specific to your microscope once again, and different scopes will have different flips and transpose associated with the data that you should be well aware of beforehand. The default will be 0, 0, 0, and that means it just has no flip up and down, flip left and right, and transpose associated with it. And of course, you will need the path to the data that you're trying to reconstruct. And so these are things you should know at the stage of taking or saving data. And it's recommended that many of these be saved in the data file name so you don't forget it or just somehow be recorded. The other half of the parameters are reconstruction parameters that control the actual implementation of the algorithm. There is the number of probe modes. We won't get into too much detail, but typically 4 to 6 probe modes are appropriate. the number of slices or layers that you want in multi-slice typography. This can range anywhere from 20 to 40 slices, and you can do less for very thin samples like 2D materials. Like in this example, or you may need more for thicker samples. For a single slice typography, set this to 1. The thickness of these slices in angstroms, typical value is 10 to 20 angstroms, and in essence, the number of layers times the slice thickness will be your sample thickness. However, using more thinner slices will not necessarily give you more information since the depth resolution is limited. N-iter is the number of iterations your reconstruction will run for. Many will converge within 200 to 250 iterations. Some might not even be cleaned up until 2000 iterations. Since you can terminate the run at any point, you can set it to a higher number and stop it once the result has converged. Save iters set the frequency of saving results. For example, setting it to 10 will save the results after 10, 20, 30, etc. iterations. The batch size I will also not get too much into, but setting it to size 32 with gradient accumulation 1 will be fine. Output dir is the path to the output directory where your result will be saved. PtyRAD will make a folder specific to your current construction inside this directory. Okay, so we went through all the minimal parameters. PtyRAD actually has a feature where you can check the validity of these parameters and see if the reconstruction will run without actually running the reconstruction and then you running into an error. So to do this, let's take terminal. You need to conda activate the PtyRAD environment. And what you do is put PtyRAD validate params -- params path, and in quotes your parameter path. So here it was demo /params / I think tbl. Oh, sure, let's do that. And this will take a few seconds, but it will tell you up front if there is a problem with the parameters. So I have invalid parameters, params, it doesn't point to a valid file. That's true because I did not actually download the demo data associated with this reconstruction. But for example, if I do the same thing with the data that is actually here, params that I was running beforehand, params.ymo. Success. It validated and everything is good to go. Okay, so what makes setting parameters and hence typography so hard is that they are highly dependent on the specific sample, experiment, and the data set, even within the same experiment. And there is no one set of parameters that fits all, and it takes careful tuning to find the optimal set. Apart from these basic key parameters, there are over 100 parameters you can customize the reconstruction with. They are separated into 6 categories: the init params, hypertune params, model params, constraint params, loss params, and recon params. And if you want to learn more about them, you can read the demo params files, which have extensive comments explaining them, like here, Or if you're not a fan of reading text files for hours, then you can go to the documentation website at this link. And if you want to know even more, the entire param structure is explicitly defined in the source code, which you can access from the PtyRAD GitHub, or I guess your full package if you downloaded it. And with these parameters, PtyRAD is incredibly customizable, but it requires a lot of experience to use it to its full potential. It's important to note that it is still possible to obtain a successful reconstruction by tweaking only these basic parameters that we have covered in this video.